There's 4 things you're going to need to prepare your NMR sample. One is a 5mm NMR tube, which is the correct size for the 400 megahertz NMR, which is where we will be running our test today. The second is a label, and then the other 2 things are the sample and the solvent. So the first thing you're going to do before you forget is make a label with your name, date, sample contents, and solvent. Then you're going to get your sample that you're running the NMR analysis on. And if it's a solid, you're going to have to dissolve it in the NMR solvent you're selecting before placing it in the NMR tube. Typically, 2 to 3 drops of sample is enough for a proton NMR, but if you're running a carbon or a 2D spectra, you'll need a more concentrated sample for better results, so you might have to do 4 or 5 drops based on your concentration of sample. After placing the sample in the tube, you're going to add the solvent. If you have any less than that, then you're going to get poor NMR results. But if you have any more than that, you're going to waste the solvents, which are very expensive. You could also unbalance your NMR tube in the NMR instrument, which could damage the instrument and also result in a poor NMR spectra. There are 5 common NMR solvents that I'm just going to briefly talk about. First one is acetone D, second chloroform D, third deuterium oxide, which is also written commonly as D2O, fourth is dimethyl sulfoxide, and the fifth is methylene chloride. For acetone D, the solvent peaks for the proton should be around 2.04 ppm shift, and it is a quintet. For carbon, it should be 29.8 ppm, it's a septet, and 206.5 ppm, which is a singlet. It'll also have a water peak on the proton NMR at around 2.8 ppm. For chloroform D, the solvent peaks on the proton will be at 7.26 ppm and a singlet, and the carbon will be at 77.0 ppm, and it will be a triplet. The water peak on the proton NMR for chloroform D will be at 1.6 ppm. Deuterium oxide, also known as D2O, the solvent peak for the proton will be at 4.6 ppm, and it's going to be a broad singlet. For the carbon NMR, it will not have any solvent peaks because it does not contain any carbons, and the water peak on the proton will be at 4.8 ppm. Dimethyl sulfoxide, the solvent peaks for proton will be at 2.49 ppm. It'll be a quintet. And for the carbon, it'll be at 39.7 ppm, and it'll be a septet. The water peak on the proton NMR for dimethyl sulfoxide will be at 3.3 ppm. And the fifth solvent that I'm going to talk about today is methylene chloride, D2, and the solvent peak for proton will be at 5.32 ppm, and it'll be a triplet. And the carbon will be solvent peak will be at 54.00 ppm, and it'll be a quintet. The water peak for methylene chloride should be at 1.5 ppm. After you prepare the NMR sample, you want to place your tube in the spinner, which is located in the NMR room, and you need your NMR sample at the appropriate depth. So there's this plastic contraption in the NMR room, and what you're going to do is you're going to place it inside the white tube and press your NMR sample to the bottom lightly so you don't break the glass. And when you pull it out, your NMR sample will be at the appropriate depth to be placed in the NMR instrument. When you place it in the NMR instrument, you want to hold it with 2 fingers and lower it gently, because there's going to be air pressure and you don't want to unbalance the sample. Next, what you want to do is you want to eject the NMR tube that is already in the instrument by pressing the eject button, and then you can see the sample comes out the top of the machine. You're going to replace that sample with your own sample as I showed before, and then you're going to click the insert button and wait until you hear the click noise, which indicates that it is properly inserted into the instrument, and then you're ready to run your experiment.